All right, welcome back, everyone. And for the second session of the morning, we're going to hear from our industry partners whose support helps to fund our workshops, fellow stipends, as well as many other aspects of our programming here at the Institute. And I'm pleased that we have a representative from each of our 5 industry partners. We've allocated up to 15 minutes for each talk, including questions. So our first speaker is Takamitsu Tanaka from Rock 360, who will be joining us via Zoom. And the title of his talk is Unique Challenges and Opportunities in Working with Residential Real Estate Data. So hopefully Tanaka will appear magically on the screen.
Good morning. Can everyone hear me okay?
Yeah.
Okay, great. So that title that was just introduced is actually my talk from last year, but it's actually a great segue, I think. So today I'm going to be talking about LLM applications in real estate. So my name is Taka. I'm the managing director and head of data and AI at Rock 360. Let me see. All right. So we're a financial firm and we specialize in residential real estate investments. And last year I spoke about the challenges of doing data science in an industry where most of the primary sources of data are unstructured. There might be images, they might be PDF documents that might come in hundreds of different formats. And then today, I'm going to speak about how the proliferations of large language models is changing our approach to these unique challenges. So this will be a talk on AI and ML application and not computational theory. You can consider it an example of how a medium-sized business is finding value in AI. So we're a company of about 300 to 400 people. I think, when you read any popular article on tech or even business, there's a lot of quote hype around AI. And I think there's, this, multi-billion-dollar, if not multi-trillion-dollar question of like, okay, AI is quote here, how are businesses going to generate value out of this? And so you can consider this how we, a small company or a medium-sized company, has started to approach this question. So one slide on business context. We're a financial institution and we specialize in residential real estate investments. Primarily, we fund business loans. We fund business loans for investors. So these can be so-called fix and flip investors who purchase properties as an opportunity, then renovate them and try to sell them at a profit. And we also have customers who want loans for rental investments. So maybe they've identified a property that they think they can rent out, and then they'll get a mortgage through us. And our customers are almost always mom and pop. We don't deal with institutional financial entities. We source these properties as well as leads for our investors, and we provide title and property insurance and other additional benefits to our customers. But the primary business is around doing these loans. And as I referred to earlier, a significant portion of real estate data is buried in documents. Every real estate loan that we make involves hundreds of pages of documents, if not thousands. If there's people in the room who have had either the fortune or misfortune of buying property for themselves, you probably remember, if you haven't force erased it from your memory, sitting in an office with a bunch of lawyers and basically initialing literally hundreds of pages of documents for your mortgage. So imagine that, except we're a business that does that. So we have to do hundreds of those a day. So the primary documents can be loan documents, appraisal documents, insurance policies, background checks, credit reports, and I'll provide examples of most of these in the coming slides. And then for secondary documents, you might want to dig up these same documents for prospective borrowers' past investment projects. You might want to look up articles of incorporations for LLCs that they've set up to be a business person. You might look up property descriptions of the properties that they're trying to source. So diving right into examples, a really important document for us is a mortgage. Every residential real estate transaction, that's a missing word, I apologize, in the United States is a matter of public record. but it's a public record that is very willfully obfuscated. So folks that do real estate transactions often set up LLCs to kind of mask the fact that there's a human behind the deal. A really recent and really public example is Supreme Court Justice Clarence Thomas, right? It came to light that corporations owned by a billionaire friend of his had bought a family member's home, right? That document is public record, but it actually took investigative journalism to figure out what was going on there. And it's very common for our customers to set up even single-use LLCs for every project. So if they've done, say, 20 fix and flip projects over the last 10 years, they might have set up 20 separate LLCs. And that makes it really hard to identify the people who are doing these transactions. And these people are customers, potential customers. So we have an interest in understanding the ecosystem. So this is a typical mortgage document out of the first page, as well as page 26. So it actually takes some effort to figure out who's doing the lending, who's doing the borrowing. If the borrower is a corporate entity, in this case, a company called Lissar Holdings LLC, then it actually takes some parsing to figure out who actually signed, which humans were actually representing this company. And so you have to go through, in this case, 26 pages to figure out what was going on. When I gave a talk last year, I described our kind of custom algorithmic approach to solving this problem, which was a combination of object detection and custom NER models. So we would do object detection on the document to identify areas like notary stamps or signature boxes, or mixed fields where there was text written in. Anything that we thought we could easily identify using object detection. And then we parsed in the text through OCR. And then we performed named entity recognition analyses to figure out, okay, is their person's name? Where's their date? Where's their corporate entity name, and so on. And this is really difficult to do at scale. I mean, you can do it for most mortgage documents and solve a lot of problems that way. But given that there's infinite variation in how these documents can be constructed, how nuanced people's names and LLC names can be, that there can be multiple people's names in such a document, including not just the borrowers, lenders, and sellers and buyers, but also agents, lawyers, offices, things like that. So, with GPT and LLMs, our approach has changed significantly. We perform OCR extraction on the documents. We do really simple TF-IDF and regression modeling to figure out where the relevant portions of the text are. And then we do named entity recognition through GPT. And we do a lot of prompt engineering to make sure that we're getting regularized outputs. And then we can then enter this information into tabular form. Another example of a document we have to deal with is credit reports. Now, you might think naively, as I did, that, hey, how hard can it be to get three simple 3-digit numbers from the front page of a report? If you look at this front page of a fairly random credit report, if you're like me, I thought this page was a nightmare. It's awfully formatted. It's very hard to tell which number is Equifax, which number is the actual report, and which number is the projection. There's random numbers in there. There's random words in there. This is an awfully formatted PDF. And it takes, to create a custom vision model to parse this is actually fairly cumbersome. But generative AI, there's a lot of out-of-the-box solutions that can do this fairly well now. Another example of something that we have to deal with all the time, but this is a nasty document. This is a table of appraisals. So off on the left, you have the subject property that you're trying to appraise. And then an appraiser will come up with typically 3 or more comparable sales that they say, okay, this is a a property that can be comparable to the subject property. And then you see this really nested table full of pretty idiosyncratic information. People can fill this format in different ways. So there's a lot of idiosyncrasy. No two appraisers use the same format. So, if you get, say, 50 of these documents, there could be 20 different formats. So this is another example of something that's fairly nasty to do if you want to build a customized approach, but that LLMs that we found can tackle this fairly well at scale. Here's another one, insurance policies. Again, lots of text in random places, no standardized format, lots of weird things, lots of weird check marks, dates, things like that. Again, really difficult to do a computer vision model for this. And since I only have 15 minutes, let me just go through. And another example of an LLM application that we found is in normalizing the they're really, there's a lot of variance in terms of style, in terms of locale specific jargon, nomenclature, there can be typos. So it's, again, very challenging to build custom approaches to extract information or classify the text. Right? For example, if you wanted to classify something that's a renovation opportunity, the text can be written in a ton of different tones. So it can be hard to figure out if it's a renovation opportunity or a recently renovated property, for instance. Extraction of specific features like close to public transit or fixer-upper. Again, you can use things like keyword extraction and keyword identification, but it becomes really hard when some of the keywords are really locale specific, right? Public transit has very different proper nouns associated with it in San Francisco as opposed to New York, for example. So you can do something really naive, like ask an LLM to generate a list of keywords for specific use cases. So here we're asking GPT to find comparable properties and then also or find keywords that might be useful for finding other properties like this one. And also finding keywords that describe a potential for renovation. And LLMs can do this, of course. But what we really want to do isn't extracting keywords, but rather extracting features, right? We want some standardized set of features like, hey, is there a kitchen island? Are there amenities like balconies or patios? Is it close to public transit? Is it near water? Is it near nature? Is it convenient? Is it near good schools? Things like that. So coming up with a rather rigid data schema and then asking an LLM to parse the description and populate this schema is something that we found a lot of success in. Early days still, but a lot of success. So what you can do is you can take these really irregular property descriptions and then have a regularized data schema that then you can use to do things like find outliers in or unique properties that are relative to its neighbors. You can do clustering and segmentation. You can use these features for valuation models or identify properties that might be good opportunities for flips. And then in the research phase, we're also doing property image analysis. Images are key data source, especially if you're trying to find distressed properties or if you're trying to evaluate borrower projects that are in progress. So we're experimenting with custom image models, including those that use that are kind of LLM add-ons to gauge things like overall condition of the home, to look for signs of damage, to look for signs that there's unfinished or ongoing construction work. And just to wrap up, so the overall impact so far using LLMs to extract information from documents is saving tens, if not hundreds of person hours per loan application. And for a business that involves so many manual PDF or manual inspection of PDFs, this is a huge process change. It enables and accelerates data schematization and normalization. It increases the volume and quality of the data that we have in relational table form. And that then expands the data that we can use in algorithms, of course. And then this approach allows for at-scale mapping of investors, their corporate entities, and their transaction history, whereas going through these tens of thousands of documents per month that are mortgage documents per month that are relevant to our industry space, and doing that on a manual basis is just not tractable. So just to wrap up, so the way we're finding value in AI in its early days, while being cautious of its risks, is we focus on extraction and parsing and not creative tasks. We make LLMs provide responses into a rigid framework. So for any task that we look into automating through AI, we benchmark its accuracy against either previous custom ML approaches or manual approaches. Right now, we're having every output be reviewed by a human. We're in the business of doing loans. These are legally binding documents. So every person every deal has a person that's accountable for it. One challenge that we see going forward is the lack of generalizability for prompts that are engineered, right? So if you give, say, ChatGPT-4 a specific prompt that you found it to work for a specific use case, what happens when a new version of GPT comes out, or when they silently change the model, or how do you then try to switch models or use something else? We see that as a significant challenge going forward. And I think this will be a kind of an industry-wide problem, or a global problem that people will have with these kinds of prompted AIs. So that's it. Thank you. I think my time is up. Yeah, I'm happy to take any questions.
All right. We could do a quick question. I think you can hear from the room. Let's try that.
Can you speak? Okay. The questioner. So I see you're using GPT-4, and then you're doing the OCRs. Now with GPT-4 Vision, do you still need to do the OCR, the other steps?
Yeah, that's a good question. I think so. We need to explore. There are two thoughts off the top of my head here. One is pricing. So if there's a cloud platform such as like Google Vision offering OCR for a certain price, I doubt that piece of the OCR is adding OCR to OpenAI or GPT is going to be cheaper. I think there's something about competitive pricing there. Another concern I have is how much visibility we have into what the AI is parsing. We don't want to get into a place where we feed any platform a PDF and then we're not sure what text that it used. By one advantage of having a separate OCR layer is that we know exactly what text we fed it. And we can also control what to feed the algorithm instead of feeding it the entire text, because we know a lot of the text is not going to be relevant.
Thank you. Thank you.
Thank you.